I'd like to welcome you all to our webinar. I'd like to welcome in particular Keith Costle, our TMS Training Solutions Director and lead trainer. I'd like to welcome Tony Smith, inventor of the Papi and creator of a lot of the standards, and very important when we're implementing standards and seeking compliance, that we understand the reasons behind it. And Keith and Tony both very well understand the underlying rationale, which is so important to help us do our jobs, to give us a good appreciation of what it's there for and how it works. And I'd like to also introduce Damon, who has actually created our webinar for us today and does all of the marketing for TMS Training Solutions and MARMS, and also for our training, online training, and has prepared today's webinar for us very kindly. So with today's webinar, as I said before, is runway lighting management. It was suggested as a topic by Jyothi from Bangalore Airport. So thank you very much for this suggestion. Who asked that we do have the topic AGL intensity design and understanding of the photometrics. This is a very high level presentation today because it's a very deep topic we're talking about. And we may in fact go into even more detail at one of our user group meetings, specifically for our customers who may want to know the secrets of how MARMS does such good measurements. But we will keep it at a high level today, so it's of use to everybody that is participating. When we're on today's webinar, please remember, just for practical purposes, there's well over 100 people here today, so with all the microphones are muted. If you have any questions, we have a 20-minute question and answer session at the end of today's webinar. So please type in your questions in Zoom in the Q&A section on the desktop or your mobile app, and then we will answer as many as we can live within the hour as possible, and we will publish when we post the link to the recording of the webinar tomorrow. We will publish the answers to all of those questions and any other questions we weren't able to get round to on our TMS Training Solutions website, and we will let you know when that's available, but it will be at the latest tomorrow sometime. And at the end of the session today, I would really appreciate if you could answer a 4-question survey to give us feedback on how we did today, and also suggest ideas for future webinars. But as I said to you earlier, the next webinar at the end of April, which is going to be on the 26th of April, will be Tony Smith, who will be telling us all about sharing with us all his knowledge of Papis, why they're so important, and how we make sure that they stay functional as designed. So without any further ado, I'd like to hand over now to our presenter for today, Keith Costle.
Yes, good morning, good afternoon, good evening to wherever you are in the world, and then hopefully you are all staying safe in these still difficult times according to COVID. Runway lighting management, today's subject. In our industry, in the aviation industry, we pride ourselves that there's no single point of failure that on its own could cause some kind of fatal accident, and as a consequence of that, the lighting that we have, both for the approach, the runway itself, and for the taxiway and apron, then is exceedingly important in low visibility, specifically in low visibility conditions. So why do we need to measure, to monitor and manage our airfield ground lighting? What does ICAO say? What does EASA say? Because we're physically in the geographical area of Europe, so EASA is the European Aviation, and we also take due considerations and full consideration of the FAA, the American Federal Aviation Administration standards. So what are they? And how do we measure AGL in terms of demonstrating compliance? And why do we measure in terms of compliance? But we really do need to have a very clear and accurate understanding of the runway visual range. Now, you need to understand what runway visual range means. It doesn't mean how far can we see the terminal over the horizon or anything or anything else. It's when the aircraft is on the runway, how far can we see the visual aids down the runway? And that is runway visual range. And there is equipment to measure that alongside the runway. And therefore, the decision to go to low visibility procedures, for example, is based upon RVR. And we in AGL provide the visual aids, the illuminated visual aids, then to support that, so that we need clear and accurate for safe operations. Now, this is a little tiny video which explains and shows, and here we see an approach. The approach being a culvert approach system. We've now getting close to the threshold, but when the low visibility, when the mist comes in, they seem to disappear. And then suddenly, then we see, oh, we're at the runway. We've passed the threshold, and now we've gone through the lower than the mist level, and we're now down at the runway, and the lights will appear again. And when we're talking about those lights, well, those standards associated with that light output is mandatory on us, according to the ISO candela diagrams in the standards. And so that's just a very, very brief clip of arriving, because what happens, especially in the mornings, in many, many airports, we get the haze, we get the mist of the morning mist. And therefore, this when we're above that mist, then we can see, the pilot can see quite readily into the distance. But of course, the pilot has to come down through the mist to land on a runway. And so that level, that band of mist means that the lighting, the runway itself, and hence the lighting, will slowly disappear from view and then arrive again. But remember, an aircraft is not stationary in the sky. It's moving very fast. And within a few seconds, then as we disappear into the mist bank and then come out of the mist bank, the lights disappear and then arrive again. And what we need when those lights appear again is like a click. And Tony will explain when we do the Papi, when we're on the correct glide slope for a Papi, he will also explain that change from white to red in a Papi signal, for example, has to be like a click. And the same thing, the same concept exists for the other lights when we go in and out of low visibility conditions. As we come into view, we need them to come back on it so they can be seen very readily, hence the standards. Next slide.
Can I just say something at that point?
You certainly can.
Because that bit of film I supplied, it's about 50 years old, actually. It was taken during the development of all-weather operations to what was then using the then standard of approach lighting. And what you actually saw was, of course, was a segment of lighting seen, which got smaller and smaller and smaller, and then it started to open out again. Now, at that stage, the understanding of fog and its structure was not what we know today. And in fact, what was needed was that the vertical beam spreads of the lights needed to be greater than they were. That's what caused that run back. And it got to the point where you could lose everything. And so in the 1980s, in ICAO visualization panel, we redesigned the lighting to have a greater vertical beam spread. But the point I want to make is that that was then designed so that once you've established a certain segment of lighting, it should never reduce. So if you've made a decision, I've got enough visual cues to continue, then you'll guarantee by the lighting that that is in fact what's going to happen. So whilst that, if you like, was a deficiency or improvement needed in the actual performance of the lights, the specification, the more vertical beam spread, what it highlights as well is, for example, if your runway lighting is poorly maintained, you may well get a good contact on the approach lighting. And then as you get near the runway, lose all visual references because the lighting that you're getting out of the fittings is insufficient to give you the visual cues. Hence the need for very, very good maintenance. It's a dangerous situation you can generate if you don't maintain your runway lighting to give you a continuous visual segment, which is maintained or increased as you get to the runway.
That's a very, very important statement. That's what you just, an explanation, Tony, that you've just given, because as we're approaching in the air, then of course we have the approach lighting, as you say, but the approach lighting, even in normal conditions, then is pretty stable in terms of the light output. But if you then go to the runway and towards the touchdown zone, which is then very highly suspect for potential dirt and rubber deposits, etc. And that will compound what you're saying, isn't it, Tony? Hmm?
Yes, indeed. In fact,
yes.
that phenomena I just described, and one of the reasons why we redesigned was there was an accident at London Heathrow around 1970, where the pilot did indeed have a good visual reference, made a decision to continue, then the runway lighting was inadequate. What he saw was the segment of lighting was decreasing. He interpreted that as the fact that the nose of the aircraft was pitching up. And so he pushed and flew into the ground. Fortunately, there were no fatalities except some horses that they got on board that died in the subsequent accident. But it was a wake-up call that we needed to look a bit more closely into the lighting design.
Thank you. So you know, we've now moved on to this slide, and it's just like you might see just a white area in the center, and the two little dots. I mean, the reality is, in low visibility conditions, that is what a pilot, when he or she is actually looking for the lights which have disappeared into the fog, as it were, then that's what they see. And it's very, very difficult, because if we're coming into an approach, the approach lights are white. It is only when we get to the last 300 meters of the approach prior to the threshold, then we have some different colors. And we have the red if you're in category 2 and 3 of the supplementary approach lights, and then the green of the threshold lights. But you see, you know, it's just a little explanation for you guys out there to say, look, it's not as straight and clear always, especially when we get in the lower visibility conditions. Next slide, please, Robert.
Sorry. Right.
So why do we need to measure and monitor AGL and manage AGL? Well, the reality is the airport operator, the aerodrome operator, has a legal responsibility, to ensure that all facilities are acceptable and compliant for safe aircraft operations. And therefore, from a commercial viewpoint, in addition to the legal viewpoint, then obviously they want to maximize the capability. More aircraft landing, more aircraft taking off, etc. More passengers. It means money at the end of the day. So it's a commercial and both a commercial advantage, but it's also a legal responsibility to do so. Airlines similarly want to minimize delays, diversions, etc. And we all know what happens when an aircraft gets diverted because of any reason whatsoever. Then the aircraft's in the wrong place. The passengers have to be relocated by other means potentially, and then the staff, the pilots and the aircrew are out of flying hours, etc. So there's a lot of issues associated that if we do not have a compliant system, whatever the system is, but obviously we're talking about airfield ground lighting, or aeronautical ground lighting is the correct formal name for AGL. And of course, regulators and the airport authorities, they are licensing aerodromes, and we have to ensure that our systems meet those licensing requirements in accordance with the regulations. So that is why. So what are the standards? Well, I've mentioned ICAO, EASA, in previous webinars, and the FAA in previous webinars. And what are those standards? So do ICAO, do EASA, for example, do the FAA, or your regional or your national standards, like, for example, CASA in Australia, as an example, then do they actually require you to measure the AGL for compliance? Is it the answer? Answer it for yourself. Do you think where you are in the world, you have to demonstrate compliance? And if so, how do you do it? Remember, one of the statements we've made in the past, you cannot manage what you do not measure. So if you're demonstrating compliance, then you will need to measure the light output in the installed situation in the field. So ask yourselves these questions, right? Are you required to measure in-field compliance using a photometric test? Next slide, please, Robert. We'll talk about that a little later. So what are those standards? Well, and clearly the international standard in ICAO is Annex 14, and it's the latest edition. The latest edition is currently at edition 8, including the latest amendments. Now, bear in mind, when we're looking at standards, then periodically the additions are released. So we're currently in Annex 14, Volume 1, which is the aerodromes. There is a Volume 2 for heliports. We are dealing with aerodromes. So it's currently at edition 8. You need to ensure, now you have to buy this from ICAO. It's a purchased document. But what we're looking at in AGL is beam intensity. We're talking about the shape and the size of the beam, the alignment of the beam, which direction it's pointing at, and the uniformity associated with that beam, and of course the color of the lights themselves. So we use different colors for different functions, and when we're looking at that intensity and we're looking at those standards, in Annex 14 there are a set of ISO candela diagrams. Now, interestingly, some of them look circular and some of them look rectangular. And I often get asked, well, why is that? Well, the reality is, from our perspective, from a maintenance engineering perspective, operational maintenance engineering perspective, it really does give us an indication of which are runway related lights and which are taxiway related lights. So the circular looking ones are for runway related lights, and the rectangular looking ones are for taxiway related lights. And it gives us a pretty quick glance at, but of course, there is a set of requirements in ISO candela diagram, which shows us the intensity in terms of the minimum average intensity. And from an in-field viewpoint, we're only interested in the inner ellipse only for operations in the field. And also under the ISO candela diagrams, there's always a set of notes. And also, there's also a set of collective notes at the end of each appendix. And when we're looking at the notes, if there is to be a toe-in, an angular, horizontal angular direction, and for example, touchdown zone lights are towed in towards the center line of the runway, and that toe-in will be in the notes. It's not shown in the ISO candela diagram itself, that if there is a toe-in, it will be in the notes. Just to be sure that you understand that. Now, ISO candela diagrams is the standard that we refer to when we do photometric compliance testing. Next slide, please, Robert. And we've got a nice little explanation here. We mentioned earlier when we were looking at a little video, and we look at when light output can disappear because of runway visual range considerations in terms of fog, etc. But when we look at an individual light, we say, what actually? Well, one of the main things is like rubber deposits in that touchdown zone area, as an example, dirt. When if you look at the inner ellipse, which I'm showing here, there's a lot of crossover points. And those crossover points are 1 degree crossover points. And we've got to maintain a mean average across all those crossover points. So how we measure is that you measure the light intensity at each crossover point, add them all up, and then divide by the number of crossover points to give us the mean average. And if we lose, for example, 1 degree at the bottom of an ellipse, and if we look here, look, you will see that you can count, there's 1, 2, 3, 4, 5, 6, 7, 8. And if we look at all of them, there's 52. Now, if we lose 8 measurement points because it's dirty out of 52, we are losing quite a dramatic percentage of light output. And if we lose 2 degrees at the bottom and we lose 17 points, we are now in an area that we've got a problem, a serious problem. So how can you measure for that? The human eye will say, oh, that light looks a little bit dimmer than that light alongside it. You can only quantify by doing a measurement. And this is a good example. Next slide, please, Robert. And so what we do is when we're looking at all our different systems, we measure light intensity by using a percentage. And we always say that at step 5, or internationally, and some nations have more than 5 steps, but when it's at maximum intensity, that is 6.6 amps electrically, then feeding the light fixture, we call that 100%. So the ISO candela diagram is based on 100%. So 100% of an approach light, which is deemed to give us 20,000 candela, is 100%. 100% of a runway edge light, which is deemed to give us a 10,000 candela, is 100%. So we base everything around the 100%. Next slide, please, Robert. And therefore, this is a nice little slide which explains where we go into the serviceable and then down into the unserviceable range. And ICAO define that in Annex 14 and the supporting documents. Then when the light intensity of an individual light drops to 50% of the design criteria. Now, the design criteria we know is the ISO candela diagram at 100%. So when it falls to 50% of 100%, then it is deemed to be unserviceable as an individual light fixture. And the guidance in the service manuals, the ICAO service manuals, give us for maintenance guidelines, they give us a guidance to say, then when the light output falls from 100%, which is the design criteria, to 70%, that light then should be deemed to need maintenance. Now you can decide that, but the guidance from ICAO says 70%. There are some national authorities which have a slightly different percentage for that maintenance. But you need to decide that. But there's the guidance. So let us now go on to the next slide, Robert. So what are those standards and do you use photometric? Now I asked that questions earlier, a little earlier. Well, the answer is in all aspects, it's a yes in ICAO, it's a yes in EASA or your national standard, and it's a yes for the FAA. And most specifically, I'm going to bring to your attention here that in ICAO, they've issued during, and I'll explain it a little later, more recently, during the pandemic, they reissued a document 9981. And the ICAO document 9981 then actually does define the criteria associated with safety and compliance. But when we're looking at EASA, the EASA, in 2021, during the pandemic, they issued the guidance on certification specifications. And that document was released, say, June 2021 during the pandemic. So there is, again, a yes for EASA. And when we come into the FAA, for those airports under the FAA guidance anywhere in the world, then if you're operating under FAA regulations, then those airports that what is called funded under the Part 139 is their 139 criteria, then it's mandatory to do a photometric test. So in all three aspects, it's a yes and a yes and a yes. Next slide, please. So ICAO document 9981, what I've just mentioned, it was released, the third edition was released during the pandemic, and it's the procedures for air navigation services, aerodromes. Now, there's a part 1 and a part 2. Part 1 is about aerodrome certification, and there are statements in there which mandate us to demonstrate intensity, beam spread, etc., for the visual aids. And in part 2, there is it talks about what we're really talking about today, operational management, aerodrome operational management, and that also includes personnel and the demonstration of they've had training, the demonstration that they are competent and suitable records are in place. So I would like to just say to you If you think maintenance is an expensive function, you try an accident. So how do we measure it? Well, the regulations, as I said, are pretty clear, and now 9981 reinforces that. Third edition reinforces that, and I've extracted just two little statements. Lights, the visual aids, lights. Out of 9981, it says lights shall have the required colors and intensity levels, and they shall comply with their serviceability levels or the maintenance objectives. We know what those colors and the intensity levels are, but you've got to measure it. Do they comply with the serviceability levels and maintenance objectives? You've got to measure it and take suitable records. So I'm saying to you guys out there, do your lights meet these mandatory requirements? And can you demonstrate it to the regulator? Can you, and we always say, would you be willing to go in a court of law in the event of an incident or an accident where there is an investigation, a legal investigation, to say, yes, my lights meet the standards, and I can demonstrate using the tools that are available. And what tools are available? There are tools. Photometric testing. There's photometric testing in the field. There's photometric testing in the workshop capability. You can demonstrate it. And here is an example of the aerodrome design manual part 4 on visual aids, chapter 17. And chapter 17, there's a nice picture of a typical photometric measuring tool. And it just happens to be MARMS. Why MARMS? Why? It's accurate, it's reliable, it's repeatable, it's easy to use, it's quick to use. So it meets the needs of maintenance teams. Next slide, please, Robert. And how do we demonstrate? Well, remember, we talked about 100%. We talked about 70% for maintenance. We talked about 50% for unserviceability of an individual light. So we use green, blue, and red in our bar chart. And the photometric bar chart, you'll see a line. So those individual lights that are above 70% are shown as green in the bar chart. Those lights that have a light intensity between 50 and 70% are shown as blue. And those that are below, that are unserviceable, are shown as red. And it's pretty clear that's the 50% line. Next slide, please, Robert. I've talked at the moment about individual lights, but there's also the criteria of when we put all these lights together in a system. And so when we put them all together in a system, then there's also some guidelines from ICAO associated with a system serviceability. And so we still use 100%. So if we look at a category 2 or a category 3 runway, for example, then at least 95% of the lights shall be deemed to be serviceable, 95%, and no two adjacent lights shall be unserviceable in a category 2-3 operation. But for category 1, where the visibility is further, that is beyond 550 meters RVR, then it's 85%. Now, when we look at individual systems, those percentages for category 2 and 3, there are slightly different. Some are 90%, but generally speaking, in a maintenance team, we stick to the 95%, so there's no confusion. And that's our target when we are managing maintenance. Even though the standards do give us some little flexibility, when we're looking at maintenance management, we stick to the 95% for Cat 2 and Cat 3. Next slide, please, Robert. So where do we start? We've got to measure the light, but how often? How frequent? That question keeps coming up because ICAO said in the guidance, at least a minimum of 2 times a year. Well, how can you have 2 times a year only right the way across the world at different intensity, at different traffic density levels, different geographical and atmospheric conditions? It's impossible to be one standard. So you have to start somewhere. So with this slide gives you a bit of a guideline where to start when you do your periodicity of checking. For edge light, runway edge lights, for Cat 1, we say, well, let's start at a 12-week cycle. If it's a center line, if there is a center line with a Category 1, so it's not mandated to have a center line, if there is a center line, then probably a 4-week cycle of photometric testing. When the visibility comes down, then we want to be a little bit more stringent. And so the edge lights for a Cat 2-3, we'd probably do it every month. And then we'll look at the records and then decide the periodicity of inspection according to the records. There are also other factors like, is it 3 aircraft a day? Or is it 3 aircraft an hour? Or is it, 30 aircraft an hour? Traffic density also has a factor. Also, how long has these light fixtures been in? Are they tungsten? Are they LED? So this element also has a factor. So we just give a guidelines of where to start. Next slide, please, Robert. So what are the factors which deteriorate light output? Electrical factors, not getting the correct current. The optical factors, is it a tungsten halogen or is it an LED, for example? Is it, the fixture itself inside? Is it secure aspect? There's the civil elements associated with where we put like inset lights or in-pavement lights. We have to put them into a base unit, which is glued into the pavement and glued into the pavement straight and level. But what if the pavement moves because of rutting? And if you go on a highway, a 2 or a 3 lane highway in your car, and the inner lane is always a little bit not as smooth as the outer lanes. Why? Because the heavy vehicles go. The lorries go on the inner lane, and eventually you get the track called rutting. Well, we have the same concept on a pavement, on a runway, especially in those touchdown zone areas, or on the rapid exits, for example. So we get civil elements. We also get the mechanical elements. Is the light fixture fixed down securely into the base unit, etc. And so that there are these factors which are fact. Now, interestingly, when you do a photometric test using a MARM system, then there is some indication on the way that the results are presented, which can give you an indication of which factors are affecting the light output. And that's an important aspect to remember. It gives you some indications. You still have to understand it, but it gives indications. Next slide, Robert. So how do we manage it? Well, we manage it in accordance with the standards and using a photometric test and take the records, look at the records, etc., etc. So what I'm going to do is next slide, please, Robert. So let's not forget, there's civil elements to be considered, there's mechanical elements, and there's electrical elements to be considered if we do not get the correct photometric output. Now, today we're talking about photometrics. We're not talking about the civil, the mechanical, and the electrical side. But if anyone wants to have training and or a webinar on these subjects, then we can do so. Next slide, please, Robert.
I think it's my turn now, Keith.
I think
We're,
so. I think now we actually get into the nitty-gritty of management of the assets.
You've left me -1 minute to do my slides. Thank you, Keith. So, so we're talking about management of airside assets, asset management. Key to asset management of your AGL is good installation, as Keith said earlier. Electrical installation, optical installation, civil, mechanical, and of course the light fixture itself. If it's not serviceable, if it's not compliant to start off with, you can't maintain it to a serviceable level. So it's vital that as part of any new installation, either a refurbishment or a new runway altogether, that you get you have measurements taken, compliance, photometric testing, basically, to ensure that the system you have acquired or purchased or installed is compliant to start off with. But that, if you have that, which you should have, you then need the spare parts and tools, including measurement equipment and an asset management system. You're measuring, there are airports with tens of thousands of assets out there. You can't measure them on bits of paper. You can't manage them on bits of paper. You need an asset management tool to manage those assets properly and efficiently, to achieve compliance and to achieve efficient operation. You need good processes and procedures. Without good processes and procedures, you can't manage your assets either. But then, of course, the vital clue of the vital bit that glues it all together is you, competent, well-trained personnel. You need to have the tools, you need to have good processes and procedures, but at the end of the day, it's people that matter when it comes to achieving and managing these systems. So an example of that would be MARM's engineer system and dashboard. All assets have the same characteristics. They have to be purchased and installed, they have to be commissioned, they have to be managed and maintained, and they have to be, at the end of life, decommissioned and replaced. AGL, however, have to be compliant at all times. It's not one day of the year when the civil aviation come. It's at all times, because when called upon, particularly in times of low visibility, those assets have to work to achieve the benefits we saw earlier, and fundamentally make sure that the pilots can have the visual cues that they need to land safely and, of course, to take off safely. The costs, it's also vital that the cost of managing your AGL throughout their life should be minimized. Cost is unfortunately something we have to consider at all times, and I think we all suffer with, because particularly with COVID, there have been a lot of cutbacks, making our lives increasingly difficult because a lot of knowledge and experience has been lost to our airports. So you need to have systems that enable you to manage these assets efficiently and effectively, compliantly. So with so many assets, you will need an asset management system to achieve that. Here's an example of MARM's KPI dashboard. It enables safe and efficient operation of your AGL system. The dashboard shows high-level measurements, the entry-level dashboard, which you can configure yourself when you use the system. It shows the 4 measurements of the key areas, including runway serviceability. A cross or an exclamation mark will indicate action is required or is overdue. And a user can drill down to each individual AGL for analysis and action by runway, looking through then to service, the centerline, TDZ, edge, threshold or end, and then to individual bar charts, which represent lights, to an ICAO candela for that particular light or fixture. Here's an example of a bar chart. Each bar represents an individual light fixture. The black ones, by the way, blanking plates. A green bar is serviceable. A blue represents a light that requiring maintenance. As Keith said, according to ICAO, once a light goes below 70% of its required output, then it's it should be identified and maintenance carried out. And of course, it should never reach red because that is unserviceable. That's effectively not working. And you can see there are some red lights on this bar chart. And as you know, that the rule of thumb would be 95% for cat 2.3 and 85% for cat 1 is acceptable. But in this case, you can see there is adjacent lamp failure. So we have two lights that are unserviceable next to each other. This means the pattern, as the pilot would see it, of the runway lights, bearing in mind he won't see very far in low visibility conditions, the pattern is destroyed, and therefore the runway lighting system is deemed unserviceable. And if you click on any one of those individual bars, what you will get is an ISO candela diagram such as this, as we saw earlier. And on the right, you can see where the image of the beam is shown adjacent to the design value, where 10,000 candela should be on the main beam. In this particular light on the top right-hand side, you can see this bit. Well, you can see the beam appears to be in the right place. It's a white light. Average candela is 12,000, which is 122% the standard for a runway edge light. This is an example of a report that shows a measurement. The top two lights here are showing each. This is the light that's just been measured with the other side of the light here. One side is unserviceable, 49%. The other side of that light is 71%. Typically, this would represent this would look to me, if you look at the previous measurement. So this measurement was taken on 16th of July, previous measurement 14th of April. You can see this light appears to have deteriorated over that time. It could just be dirt that's accumulating, or it could be more likely on a halogen installation that the actual filament of the lamp is deteriorating and that lamp actually needs replacing. On the other side of the light though, the performance is also deteriorating, but it's not as bad. So typically it will be a combination of dirt, particularly you will get one side of the lamp with in the prevailing wind direction or takeoff direction, which will suffer more damage to the lens, for example, than the other. And so you will get often see one side of the light better than the other. Touchdown zone lights are, as an example of lights like the runway edge lights that need to be towed in. You will see, they're unidirectional lights. These can either be a straight fitting in a towed can or a towed fitting in a straight can. We often see issues where towed fittings are used and they're put in on the wrong side of the runway. This is easily identified on a MARMS course bar chart because the ellipse will not be at the same place as the brightest part of the beam. Here's an example of a course bar chart where you can see the beam is significantly in a significantly different place from the ellipse. On the top diagram, you can see the beam is probably a little higher than it should be, but it is pointing centrally. On the bottom ISO candela, you can see the beam is high and to the left-hand side. And this is, by the way viewed looking from the inside of the light, looking out. Reasons for problems you will identify from an ISO candela diagram is alignment issues, such as this. The fixture is not towed where it should be. It could be towed the wrong way completely. You will see rubber deposits reflected by dark patches on the beam. The internal mechanism, there could be problems when the lights are put together. The internal lamp components are assembled incorrectly. And indeed, there are even cases where the light, of course, is completely out, where the ISO candela diagram comes out black. This is another example of reports to assist the people maintaining the runway, where you get the course bar chart, and this report shows the map of the light. So you can see the third light the end is completely unserviceable on this well, it's on both sides actually, but this course bar chart represents one side. But you can see on the map which end of the runway to go to avoid any confusion. Now, I know in the past I've seen lights. I've seen the wrong light, maintenance taking place on the wrong light. It's important the reports clearly identify where you are. You can of course use with our system the tablet to give you directions to an individual fault. But if you're going to go out on the runway without a tablet, you can use paper reports such as this. Then we come to the runway service, the runway measurement charts. This one shows the number of faults, number of assets that are at fault in an area, or unserviceable in an area, and the number of faults in an area. You can get more than one fault per asset. For example, you could have a photometric fault and a torque fault, so that accounts for the difference. And you can also set, in a modern asset management system, you can set a time limit for fixing faults so that you will know if those faults are actually being fixed in the time, in the service level time that is specified for it. And if they're not, then you will get the shriek mark here to indicate there's a problem. And if you click on that, that will take you through to the detail of the individual asset, and you can see what the problem is. MARMS can also be used to identify all the current faults on the airfield from the various sources, not just the photometric faults we've been looking at earlier, but also faults imported from the control system, from visual inspections. They can all be reported onto the airfield. Also for other assets, you can see the Papis marked on there. You can even using a modern asset management system, mark out the civils layers. But if you click on any one of those faults, you will get a fault status report showing you for the asset what the problem is, and then you can click on one of those reports at the bottom to get the bar chart, the history, the ISO candela reports, and any other information you need to identify fixes for that problem, for that light. And then finally, there's the asset hotspot report, where you can select over a period of time the faults for an area, and you can see according to how red the light is, the red indicator, to show you where there have been multiple faults and how many multiple faults. So in this particular instance, you can see on the center line here, where, as you might expect, by where the rapid exit is, you'll see that there have been more reports reported on these lights than the lights, for example, after the rapid exit area. And as I said, the redness will indicate the number of faults there, and you can click on them to identify the relevant information again to assist with your asset maintenance. And then you come to my favorite report, which is the asset history report. So often we're trying to fix lights where there is a problem more significant than maybe first thought. So, for example, if you look at the top lights here, L86/9, you can see that this light has been 30–40%, and it's been cleaned, no doubt. But then here, this marker here shows all the lights were cleaned. These lights all improved significantly, but this particular light only improved. It was still unserviceable when it was cleaned. So then it was changed as marked with a, and when it's changed in the, we're using the asset management, MARMS asset management, MARMS engineer system, you get a pink marker and you can see immediately the photometric performance improved. So there was not an issue with the location. Cleaning clearly made no difference or insufficient difference. And it was that light needed to be replaced. This is in fact an LED runway. So, you know, so you don't have the issue with the incandescent bulbs. So, and so it's very helpful to know if you've taken some action if the cleaning has actually fixed it or not. In every case I can see here, when the light is replaced, the photometric performance has recovered to be serviceable. Here, however, though, there's an instance where the light actually, there was actually a problem. I don't know quite what's happened here, but it's actually gone down. But then I think that light has been replaced again, and it's gone back up to 252. The bar on the left shows it's a red light, so that's a white. So we're in the red-white section. And for your information here, these buttons here show, for example, here, this light in the last 12 tests has failed 12 times. So that's 12 times in a row. This light, if I'm looking another example, if you, yes, all of the other lights have passed in their most recent test, but it would show how many consecutive failures they've had since they were last serviceable. But they've all been, apart from this one, they've all been serviceable since their last test. And then we come on to the philosophy, the maintenance philosophy that we employ in TMS, and that's the differential, MARMS differential maintenance. It's based on measurements and standards. You first of all measure to collect accurate, reliable and timely performance data. You'd use a MARMS photometric system, photo bench, to test in the workshop to make sure you don't put any bad lights on your runway. You would have a sign and Papi test, MARMS sign and Papi tester for your signs and your Papis, and a MARMS apron and stand tester for your apron and stand lighting measurement, and of course the asset management tool to record and hold all those results and present it in the dashboard. You then perform maintenance based on the measurements you've taken, the work being scheduled and targeted when, where and what as required. If it isn't broken, you don't fix it. Runway access is at a premium, as we all know, so that's absolutely core to our philosophy. And you use tools such as the MARMS airfield torque wrench, MARMS cleaner, a MARMS rapid serviceability tool, and MARMS engineer again to schedule and manage your maintenance and to conduct your planned preventative maintenance actions. And then finally, you monitor the results of those and the effectiveness of your maintenance work using the MARMS dashboard. You measure and check your airfield lighting serviceability for compliance, your torque status, make sure everything has been torqued at the required service interval. You would look at your installation resistance statistics to make sure you don't have any circuit issues and use the tools if required to address those issues. You monitor task completion, so have the inspections been done, have the torque checks been done, have the lights been cleaned according to schedule, have the photometric tests been completed according to schedule. You look at your fault status to make sure they're all complete, all the faults are fixed in the prescribed time that's allowed for fixing any faults. And then all this data is recorded in the database and provides an invaluable tool to help you manage those assets as a whole, using heat maps, asset history, measurement trends, drill down reporting, IRVR reporting, and key performance indicators. And this will help you manage the overall life cycle for your asset. So for example, if the maintenance is becoming more and more frequent, and it'll enable you to identify, for example, that the domes on your runway edge lights are becoming pitted, and therefore you need to replace them, or indeed potentially replace the lights altogether, but or schedule a replacement of the domes based on the measurements you're taking. So you only do maintenance when it's required, you only do what is required and where it's required. You can't manage what you don't measure. And so the whole point of this is to benefit the airfield. As I said, counting down to in order of benefits, sixth best benefit, it enables your airport to demonstrate to its stakeholders, which is all of the people that work at the airport, the airlines, the regulators, government, the owners of the airport, that the airport is operating safely and they're gaining operational advantage as a result, direct benefit of the work you're doing. It reduces the number of occasions where the pilots complain of glare because they're having to increase the intensity of the lights unnecessarily to overcome a number of dirty lights or faulty lights, for example. One of the key benefits nowadays is reducing CO2 emissions, because by improving your IR/VR results, you're able to reduce, to delay going into low visibility procedures, and you'll be able to accelerate coming out of low visibility procedures, which means less aircraft holding unnecessarily, which is a huge benefit for your airport and a huge benefit for the environment. You will be able to increase capacity as a result because of this delayed onset of low visibility periods and accelerated coming out of low visibility periods. The chances of a successful landing and avoiding go-arounds and potentially diversions is of course increased by a result of your improved maintenance, less unscheduled maintenance interventions. So that's a huge benefit for the airport and the airlines. And of course, ultimately, the number one benefit is improved airport safety. Pilots approaching in reduced visibility will be receiving the visual cues they need to land and take off safely, by the way, and they will get accurate runway visual range readings. They will not be overstated because the lights aren't working as well as they should be. So in an actual works example case study we did for a major international airport, we calculated for each low visibility day, there were 37 minutes gained by virtue of improved RVR data, which translated into 24 additional landings and 24 additional takeoffs per low visibility period, which was a huge, huge benefit. So this is so important. I mean, for safety, but also for the airport's benefit of the airport. So that's why we have to do our work and manage our AGL and compliance as efficiently as possible. So Keith, that's I think we're just on time now. If you could just quickly wrap up for us and with what's happening on our training.
We've been exceedingly busy with training. We've come out of lockdown, and of course we're in this runway to recovery period for everyone, and so we have the runway to recovery bespoke training. We've dedicated some training to bring everybody back into really competence, compliance, etc. So that, remember, I've got a really good friend who says learning is something that no one can take away from you, but you need to be able to demonstrate that you have learnt correctly. That is, you gain knowledge, you can apply that knowledge as skill, but what we can't change is people's attitude. So if you've got the correct attitude, then you put the three together, and then we can define competence. So runway to recovery in the 25th to 29th of April. We've got a design training week. We're doing week one. Now, our training is normally 2 weeks for design, but with week one, so we're going to do week one, 23rd to the 26th of May. And we want to do there's designers. And week two is an optional week, so we have that in the program, but also to bring your attention to the maintenance training, and that's going to be the 6th to the 10th of June, and then we also have some additional training in terms of bespoke training in October. But the maintenance training, I think, in June would be very attractive, especially in the light of, together with the runway to recovery and then the maintenance training, because this is the key subject of managing airfield lighting, managing the lighting. So they're the two things. Now, all these now are done in accordance with the latest guidelines. Now, the guidelines are given to us now in that document. I said ICAO document 9981, third edition. Now, in part 2, it defines that it is mandated on aerodrome operators that all persons involved in operations shall, okay, have the appropriate training, records, etc. So I'm just bringing that to your attention. So this is a little, now you can get this off the website at www.tmstrainingsolutions.com. So if you look at the website, you'll be able to see these. So
Keith, we'll circulate this. We'll circulate this with the notification of the of the training. Sure. And now, just bearing in mind time, I'd like to, as you can see, the next TMS Tuesday is Papi's. Are they really aligned and serviceable? And Tony has been extraordinarily patient with us there. And I just, if you could just give us an introduction, to what you're going to be, talking to us about next month.
Next month.
Yes. The 26th of April.
What I hope to do in a month's time is to address the demystification of the Papi, the appreciation around the place that somehow this is a difficult piece of equipment to own and maintain. With the equipment that's now available for in-field monitoring, it isn't difficult to maintain, I would say. In the prototype days, we didn't have all this equipment and there had to be more manual input. But today, if you have the right equipment, you can maintain it correctly. Behind all of that is an understanding of what Papi is. And I've been saying it more and more recently. Look, what you're dealing with is a slide projector. A slide projector that is focused not at the distance your screen is away from your projector, but focused at infinity. So that that means the red-white picture you get has a very sharp boundary between the two colors, and not only sharp boundary in color, but a sharp boundary in intensity. And those two together result in a signal which, when seen as a pilot passes through that transition, it's a very abrupt change from one state to another. So it's very easy for the pilot to know instantaneously where he is, if he's too, or she is too high or too low, or deviating. That's the great advantage of Papi over other and earlier designs. It's instantaneous, very evident that you've got changes, but you must have this sharp transition of color and intensity. And I want to say a bit more about some equipments I've now seen on the market where only part of the specification is addressed. In other words, the color change and the intensity change, roughly 5:1 in the original design, is an important part of the feature. In fact, it's almost like flashing a light. If you go 5:1 in change of intensity, it's rather like switching a light on and off. It's not a lot different in what it does in your peripheral vision and indeed in the central vision. So that there are things being fed now into design which are going away from the original design. And the other thing I want to bring out, perhaps importantly, is you can't do calibrations and changes to Papi in the field. The Papi should come, as it were, as a sealed unit, that it has within its design means by which you can align it accurately. And if you regard it similarly in that sense to a theodolite, you would never consider taking a theodolite apart in the middle of an airfield. If there was any problem, you'd take it back to the maintenance facility or indeed to the manufacturer for recalibration. So the Papi should come with inherent stability of signal, but that still doesn't mean you don't need testing. You do need to test both in the initial installation to ensure you're compliant with what the manufacturer has said he's supplying, and then the continuing maintenance that the Papi is indeed giving the right color, the right beam spread, and the right transition, the smallest, very accurate transition, and where that transition is in elevation angle. Those things, it isn't just about the setting angle, that's one part of it, but beam spread, everything's important. That all needs to be measured. And I would say one of my bête noirs is so-called pilot flight checks. They never were much use, and they aren't today. They don't have, if you do a few sums, you'll soon convince yourself they're not accurate. So they're not accurate enough for checking Papi setting angles. And if I go back to my early days in this business, one of the first things I did was look at light output on runway center lines, and found that runways that have been passed by the regulatory authority within the last 2 weeks as being compliant had got less than 2% light output. That's how good a flight check is, potentially. There are a lot of things you can't actually really measure just by flying through the system or around the system. You need calibrated, ground-based measurement facilities that are calibrated, which are referable back to international standards in terms of the photometry and the colorimetry that is being used. Anything else? Don't go away with the idea that a quick flight check will say that your Papi is serviceable.
Does that include drones, Tony?
Drones, I think I've yet to be convinced that the drone can do the job, both in terms of positional accuracy and height, which will be crucial with the civil GPS that we have. If that can be proved, well, good. At the moment, I know from way back, height has always been a difficult channel to get accuracy. If it wasn't, I think we'd have dropped ILS a long time ago and gone to precision approaches using GPS. It hasn't got there, and one of the big issues is the accuracy of the height information. The other accuracy, of course, is it's not the same as a Mark I eyeball, a camera. And it's what the pilot actually sees that matters in terms of the sharpness of the transition. Now, you can do it by laboratory measurements, but an in-flight check with a camera that has different characteristics to the human eye, it again, is potentially fraught with difficulties, that you'll get accurate measurements.
Right. Well, thank you for that, Tony.
There's a question that came up, Robert. I
Yes.
saw there's a question that's come up, and he said, I'll bring it up. It says, is MARMS the only monitoring measuring system available in the market throughout the world? I mean, the answer is no, but I would repeat the fact that, your photometric measurement system, it needs to be reliable, it needs to be accurate, it needs to be repeatable. So when you do one run and then do another run, you do get the same results. It needs to be easy to use, it needs to be robust, etc. It needs to be quick to use. There's a lot of factors which not all the systems, there are some other systems available, but not all the systems meet all this criteria. And also, is the recording automatically into an asset management system?
Yeah.
And also, all the parameters need to be measured. It isn't sufficient just to measure where the setting angle is. You've got
Correct.
to look at beam spread and color.
Yes.
Yeah. So there are. I mean, ultimately, I mean, we could always have leveled at us that we're biased, but I would say ask other airports. We work very hard to be the best we can be. There are other systems available, but the most important thing is you do photometric testing as regularly as is necessary on your runway, and you do the maintenance based on those results to achieve compliance, because there are too many airfields out there that don't do any photometric testing at all, and that is, frankly, it's shameful in today's day and age. And as a member of the flying public, I find it I mean, people realize that airports did not maintain their runway lighting, which is what this amounts to. I am appalled, and everybody that flies in airplanes should be appalled, because in low visibility conditions, it's really important.
Yeah, and if you have the tool, Robert, say you have your photometric tool, that's which we've spoken about, the MARMS photometric tool, for example, then it's a measuring, it's a calibration tool, isn't it? So it needs to be calibrated periodically. So I would suggest that from from an engineering viewpoint, then if I've got any tool, I would need to, for example, recalibrate maybe the sensors once a year. Is that logical?
Absolutely, yes.
Okay, thank you. Mm-hmm.
Right. Right. So can you see, have you got, can you look at the other questions, Keith?
There is one, it says many CCR disconnected by remote mode, others are okay. What is the problem? I think we need to, if we contact us directly, I think this needs a little bit more analysis of the question and find exactly, then we can give some guidance on that. And another question is, if the lights is not every one at 60 meters and is 62 or 64, what happens? What he's really saying is the spacing. If the spacing of lights, and we're talking, I think, where it says 60 meters, so we must be talking runway edge lights, so some are 62 or 64. Well, the guidance in for a precision runway is that they shall be no greater than 60 meters spacing, and they should be equally spaced, spacing no greater than 60 meters. So I think there's some issues associated with design there, I would suggest.
Keith, I would say that, the key, one of the things I've seen, I saw at an airfield last year, an installation where the lights were not, they were not parallel with each other. So they'd taken the 60 meter spacing, and they were not parallel with the light on the opposite side of the runway. And I think that was more dangerous because of course, in low visibility conditions, you'll only see one light. You'll see one light on one side. I think they
also, Robert, and I think Tony will, because Tony, remember when the early days of illuminated visual aids and those practical trials that actually Tony actually did them or was involved with them, and the fact is that when we're looking at the lighting systems, we're looking for uniformity. And it's when you have not got uniformity, when the doubts come in. And if the doubts come in to a pilot who is traveling at 150, 200 kilometers an hour, for example, then that is an issue. So what you're talking about there, Robert, is uniformity. And I think, Tony, you will agree, uniformity was a key issue in all those practical trials.
Right.
Yeah, I think the best way of looking at this is to take the worst case, because the lighting is designed for the worst case. Frankly, if you were operating in clear visibility, just a night landing, if the lights on opposite sides of the runway aren't quite on the same line, I don't think any pilot will ever complain about it or even notice it. Where it will happen is where it will start to impinge is where what you actually see is only 2 or 3 lights. And if there's a significant difference in the longitudinal position of the two sides. If you imagine on the right-hand side, they're further up the runway, that can give you an impression that the aircraft is rolled slightly.
Yes. Yes. Yes.
So there's everything to be gained by getting it right. You potentially go into an uncharted minefield by not doing it. So why would you not take the trouble, as you say, at the design stage to get it, and maintenance installation stage to get it right? Because having said that, there will be situations where the pattern isn't fully implemented. For example, where a taxiway comes into a runway, it may be that one of your taxiway lights to maintain the runway light edge lights would have to be in the middle of the taxiway. Now you could perhaps put an inset center fitting there, but frankly, if there was just one light missing there, I don't think we're going to cause an accident, frankly. But this should be exceptions and should be looked at from the point of view of what does it mean operationally.
Yes, yes, I totally agree with you. The fact is what you were saying, Tony, certainly that roll factor in that low visibility scenario when fast decisions have to be made.
Yeah.
And that roll factor, it could, you know, if you have a displacement and not a uniform pattern, a displaced pattern, then that could create result in an incident. As you say, pilot adjusting his role is you know, on his artificial horizon.
I can't recall any accident report saying that something like this was present and caused the problem. That doesn't mean to say, hey, that it never has.
Yeah,
But my point is, you guard against the possibility by doing it according to the ICAO standards. Why put yourself into potential danger or any potential difference by not meeting those standards? Why do something different?
that's where the hazard analysis comes in, and the risk factor.
Yeah.
So is this all part of the safety case, or a safety analysis, which is part of the aerodrome manual?
Yeah.
Thank you very much. Thank you very much for that. We've quite exceeded our time this week, but I'd like to thank you, Keith. I'd like to thank you, Tony, for your contributions today. I'd like to thank the team, Felicity and Damon, for all the work they've done to make this happen. And most important of all, I'd like to thank you, the audience, for spending your time and sharing your afternoon with us, or morning even, with us today to participate in this webinar. We hope to see you again in 1 month's time, where Tony will be sharing his immense knowledge and experience of Papi's, and we'll be answering any questions you may have. So please feed those in. Please take time to answer the questionnaire at the end of this, and then we will let us know any suggestions for future webinars. And thank you very much, and have a lovely rest of the day wherever you might be. Thank you very much, everyone. Bye-bye.